The transportation problem. Okay, so we will develop an algorithm to solve the transportation problem. Remember, what is the transportation problem? We discussed such a thing in section 4.1. But let us recall together what was the problem, what the problem was about. It was about having some plants or factories producing some products. So we will say plant number one, plant number two, plant number I to plant number N. And we want to ship the products from these plants to warehouses. So we will say warehouse number one, warehouse number two, all the way to warehouse number J, to warehouse number M. So we assume we have N plants and M warehouses. Okay. Okay, that's applied. Okay. I want my notation to be consistent with the book notation. So I will assume we have M plants and N warehouses. Okay. Now we want to ship from plants to warehouses, factories to warehouses. But there's a cost for shipping. Shipping from plant 1 to warehouse 1, the cost we denoted by C11. Shipping from plant 1 to warehouse 2, we assume the value is C12. And all the way from P1 to WJ, the cost is C1J. And also from 1 to WN, we assume the cost is C1N. Okay? And we do the same thing for shipping from any other plant to any other warehouse. So in general, we will assume that shipping from plant I to warehouse J has cost CIG. Now the question is to find the values xij that represents the amount I want to ship from plant I to warehouse J. I want to know how much shall I ship from plant 1 to warehouse 1, plant 2 to warehouse 2, plant 2 to warehouse 3, plant 2 to warehouse 1, plant 3 to warehouse 5, and so on. If the problem here is to find how many products shall we ship from each plant to each warehouse so that we minimize the cost of shipping. Maybe we don't have to send from every plant to every warehouse. Maybe we will not send anything from plant 1 to warehouse 5. We send 0, that's fine. So these are the question, the quantity. So let me say here xij is the quantity. So let me write it somewhere in black. The amount I send from plant I to warehouse J, we denoted by xij. And therefore the cost will be, the cost function will be Cij times Xij, because Cij is the cost from shipping from plant I to warehouse J, and Xij is the number of units we want to ship from that plant to that warehouse. So if we do all that multiplication for all I and J and then add them all together, then we get the cost function, which is here, and we want to minimize. And there are some constraints to this process because every plant has some capacity for supplying. So we will assume plant number 1 can supply S1 products, 100 maybe, or 80 or 60 products. Plant number 2 can supply S2 and so on. And then plant number I can supply SI. On the other hand, each warehouse will have some demands. So, say warehouse number 1 has wants like 100 or 50 of these products. So we will say the demand for warehouse number 1 is D1, the demand for warehouse number 2 is D2, and so on. The demand of warehouse J is WJ, and we keep going. The demand of warehouse WN is DN. And if you complete this, the supply of plant M is SM. Okay, so for sure, the constraints will be as following. Sorry, the number of units we ship from all plants to all warehouses shall equal the number. Sorry, no. Let me explain that. In here, it says, let me write this in here. We have discussed this before, but let's do it again. So we are fixing G here. So we say from plant 1 to warehouse J plus the amount from plant 2 to warehouse J all the way from plant now from plant N to warehouse J. Okay, from plant. Okay. So I film plant into warehouse J, okay. That shall equal the amount that the plant I mix. So sorry, I want to go back here. My notation at the beginning were fine. We want to use N for number of warehouses and M for the number of N for the number of plants and M for the number of warehouses. Okay. Now this equation here says the number that we are supplying so J equals on I mixed notation. I mixed sorry. X J is yes. J is changing here. Sorry. So I need to change this. Forgive me for that, please. Let me take off everything here. J is moving, I is fixed here. So we will say from plant I to warehouse 1, and then from plant I, we are fixing I here to warehouse 2, all the way from plant I to warehouse N. So I will go back and change the indices again. I want my indices in this diagram in here to agree with the indices of the book. So this is again how many warehouses. We have warehouses in warehouses and M supplies. I wish did not confuse you. Okay. Okay. So this is an explanation of one of the constraints. The summation of xi, 1i, 2i, 3i, n shall equal the supply provided by plant I. And in here it says the summation of x 1j, 2j, 3j shall equal the demand of warehouse J. So the summation of x1j, x2j all the way till xmj. So these are the amounts received by warehouse G, and that shall equal the demand of warehouse G. Okay. And also this constraint, the number of supplies must be equal the number of demand. Okay. So what I have done so far is just recalling the transportation problem that we have seen previously in details. And what we are looking for are the values of the xij so that the cost, the shipping of cost, the function up there is minimized. Okay. Now, to make this more sensible, let us assume we have three plants. And here I will write this is plant number one, plant number two, plant number three. Okay. And I will reserve this space for a while. So let me uh, leave some space. This is plant number one, plant number two, and this row for plant number three. This is warehouse number one, this column on earth for warehouse number two, warehouse number three, and warehouse number four. Okay, now what we do here. Now the first column is for warehouse number one, and the first row is for plant number one. So in here, in this box here, we will say this is C11. This is the cost of shipping from plant one to plant two. But in here, it is the cost from plant one to warehouse one. Here it is the cost from shipping from plant one to warehouse two. Here it is the cost from shipping to plant 1 to warehouse 3. And here is the cost of shipping from plant 1 to warehouse 4. Okay. Again, this is the cost here of shipping from plant 1 to plant 2 to warehouse 1. This is the cost of shipping from plant 2 to warehouse 2. This is cost of shipping from plant 2 to warehouse 3. And so on. This is now here 4. And you can complete that. Now it is C31, C32, C33, and C34. And why do we need these spaces? 4. In here, there will be a number which is supply 1. Let me write them in different color. We'll write a number here, supply 1 by plant 1, supply 2, supply 3, and in here, demand 1 by warehouse 1, demand 2 by warehouse 2, demand 3, demand 4. Now, what we are looking for are the following values. The amount we ship from plant 1 to warehouse 1, the amount we ship from plant 1 to warehouse 2, the amount we ship from plant 1 to warehouse 3, and so on. So this is a 2-1, x22, x23, x24, x31 from plant 1 to warehouse 1, x32, and from plant 3 to warehouse 3, and this is the amount from plant 3 to warehouse 4. Okay, so we will do this modeling for the transportation problem in general. And for this special case, we restricted M to be 3 and N to be 4. Okay, for example, if we are given this matrix, this is called the cost matrix. Cost matrix. And now in Salt Lake City, this is plant number 1. There is a factory in there. Plant number 2 in Denver, and plant number 3 in San Antonio. And we want to ship to warehouse number 1, which is in Los Angeles, warehouse number 2, which is in Chicago, warehouse number 3, which is in New York, and warehouse number 4, which is San Antonio. So we have a plant and a factory in San Antonio. Okay. Now let us take these numbers. These are the supply numbers and these are the demand numbers. Let us take all this information and plug them in that table. So what we get? For the supply, we get here 120, 140, and 100. So this is the supply of P1, this is supply of P2, this is supply of P3. For the demand, warehouse 1 and W2, this is W3 and this is W4. We will not be writing these P's and W's anymore. So warehouse 1 need 100, in here 60, in here 80, and in here 120. Now we are looking for how many we shall ship from warehouse 1, from plant 1 to warehouse 1, and so on, as we have mentioned before. But I want you now to know that if I add x1, 1, x1, 2, x1, 3, x1, 4, I must get 120, right? Because this summation of x's is the same as the number of supplying by plant 1. So I'm again explaining. So I want to remove all these now to equalities just to make explanation easy. And here I'm explaining why this equality is happening. Add the rows of the x's, we get the number to the left, to the right, sorry. Now add columns, we will get the numbers down there. Okay, so if we keep going now, again, this is x21, 22, 23, 24, and x31, 32, 33, and 34. These are the values we want to obtain. Again, if we add these x's, we must get 120. And if we add these x's, we must get 60, and so on. And for sure, the cost now the matrix is given. This is 5, 7, 9, 6, 6 in here, second row. Cost of shipping from plant 2 to all warehouses. Okay, good. So this is the modeling. This is the table that we will be working on or playing on so that we solve the transportation problem, so that we obtain values for x's that minimizes the cost. Remember the cost, how we compute the cost. We multiply c's with x's. So to compute the cost, we multiply these together. We get the values and multiply these, all the way, multiply them all together, and then add the result of all these multiplications. Then we get the cost. This is what we mean by that, right? Okay. Now for this specific problem in here, we're still working with it. I mean, this is the cost function is written that way. Now we want to write it explicitly, the cost function and the constraints. Why? Because we want to get the dual problem out of it. We want to take the dual problem, the dual variables. And here we go. Now taking the dual, you know how to do that. Take the coefficient of these. Okay, now this constraint here will introduce a variable for the dual, which we call V1. This constraint here we call V2. This constraint here we will call it V3. And for this one here, we will call it W1. We are free to choose these names, right? We can make them W1, 2, 3 all the way. But we want to give two letters, two different names to the variables of the dual problem. Why? To make things go smoother later. Okay, so we call some variable VI's, okay, and some other variables, wi's. Notice that the vi's went to the variable of the uh, the variables vi corresponds to the constraints that are the supplement constraints. These ones. So for these ones in here, we named the dual variable to be vi, and these ones in here we named the variables to be wi. Okay, for some reason. Now, if I ask you to create the dual problem, then I think you can do it easily, right? You will take, sorry, okay, let me use the highlighter. You will take the coefficient of this and that, okay? And this goes for V1 in here, and this goes for W1. So the very first constraint in the dual problem will be V1 plus W1 equals what? The very first coefficient in the cost function equals 5, which is equals C11, right? Okay. And then what else we get? If we keep doing the dual problem, actually, uh, we will have the constraints of the dual problem just to be this way. Okay. Now again, if we go and do another highlighting, this one and this one with this in here, which is C12. So we will have V1 plus V2. This goes to W2, sorry, equals 7, which is C12. Now, if you notice in here, it is 1, it is 2, and here it is 1 and 2. In general, we will have Vi plus Wj equals Cij. This is the dual variable, and the objective function is to maximize. So you multiply each one of these with, this is with S1, with S2, with S3, the ones that are in the constraint. And this is with W1, D1, sorry, D2, D3, and this is with D4. And then we get the objective row of the dual problem. You know how to do that. Here we have done it. So what do we want from the variables, the dual variables? We want this Wi plus Wj for the basic variable. Now here we use the complementary slackness to conclude the equality. At the beginning, actually, it was inequality. I should draw it here. It was inequality, but using the complementary slackness, we can show it is equality. And I will let you go back and see why this will guarantee the equality for us. Now, this is what we want to take with us. When xij is a basic variable, this is j. When xij is a basic variable, then vi plus wj equals cij. Okay? We need that to solve the transportation problem. Remember, this applies whenever we have a basic variable. Okay. Now, to start the transportation problem algorithm, we must start with an initial solution. How we choose the initial solution? There is a rule that is called minimum cost rule, and it says For each row, assign the maximum possible amount of xij to the cheapest route. Okay, what does that mean? Let us see. Okay, so I will explain the transportation algorithm using this example. So consider the transportation problem between three sources and five destinations, in which the supply vector is and the demand vector is. Okay, now this is the supply vector. At the right of the table, we will have the supply is 100, 160, and 140. And in the row, the bottom row, we will write the demand 90, 60, 80, 170. Okay, and now in the boxes there in the corners, it is giving me the costs as we have seen before. Now, the minimum cost rule says choose send the to the cheapest route. So I will say I have this 100. I want to send everything to the cheapest route. So where is the cheapest route? This is 3. Okay, so I will send all the 100 to 3. But I'm not supposed to do that because this warehouse here needs only 60. So I said, okay, I will send 60 out of these 100 to this warehouse. But I have 40 left from this plant. So I will say, okay, let me go to the second cheapest route, which is this one in here, and fill the remaining, which is 40. Now, this 100 from plant 1, I send it to warehouse 2 and warehouse 5. Okay, good. So I'm done with it. I will repeat the same thing for 160. So I will look for the cheapest in this row, which is 2. Okay, now 2 in this cell corresponds to warehouse 3, which needs only 80. So I will say, okay, I will send 80 here. Now I have another 80 left behind. So I will look for the second cheapest, which is 5. And I say, okay, I will send this one 80 again here. But I cannot do that because if I do this, I will be sending much materials than warehouse to demands. So I cannot put an 80 in here. So I will look for the next cheapest, which is 6. Okay, and this warehouse here needs 70. So I will say, okay, I will give you 70, but I cannot do that also because this warehouse already took 40. So I can only send 30. Okay, now I have 80 and 30, 110, so 50 are left behind. I will look for the cheapest, which is 7, and said, okay, take the 50, as I will send them to warehouse number 1. So I'm done with the second supply. Let us go to the third supply. Okay, let us look for the cheapest. It is 5, and this warehouse needs 90, and 50 are already sent to there, so I can send 40 more. Okay, so I have 140 and in supply 3 and 40 are sent to supply 1. No, sorry, somebody fix me maybe. The cheapest route here is, I did not pay attention to it, it is 4. 4, so I will go to 4. Okay, so I will go to 4 and it needs 60, and it has already taken, so I cannot actually send anything from it to there. So I must put zeros in here, 0 in here, 0 in here, so that I avoid sending to these things again, and 0 in here. Right? I cannot send more. So the 140 will go to 5, okay, and I can send 40 only, and I have 100 left behind. Okay, I send them here, and we must have zeros there. And this is what we call the minimum cost rule. We needed just to make an initial visible solution as in the simplex method. So this is not the solution indeed, right? Make I will let you compute the cost for this solution. It is 3 times 60 plus 3 times 40 plus 7 times 50 plus 2 times 80 plus 6 times 30 plus 5 times 40 plus 8 times 80. Add them all together and see what is the cost, the total cost. Now we need to adjust uh, our table. We need to do something new. Now we go back and use this here. Vi plus Wj equals Cij. And we want to find these values. Okay. Now V1 plus W2 equals C12, which is 3. Where is C12? This is C12 in here, right? V1 plus W5 equals C15 equals 3. It is in here. Now we are only taking Vi plus Wj for the basic variables that are highlighted in green only. Now next we will take V1 plus V2 plus W1, which is C21, which is 7. If we go here, this is C2W3. So we will add V3 plus, sorry, this is C2 3. So we will go for V2W3. There we go, and this equals 2. And this C2W5, C25. So we go to V2W5, which is 6. This one in here is C31. So we go for V3W1 and it equals 5. This one here is C3W4. So we go for V3W4 and it must equal 8. Now we solve and we can assume V1 equals 0 because remember V1 and VI, Wj were greater than or equal to 0, right? Or they were unrestricted actually because we have equality. We can go back here. Yes, they are unrestricted. So we are choosing initial solutions. We are improving. So we can assume an initial value for V1. So if we assume that initial value for V1, so using A, we will conclude that W2 is 3. Now W2 is 3. Okay, we know V1 is 0, then W5 is 3. Now, knowing that okay, go to E. We know W5, we already found it, so we can know what is V2. And play with that, and you will get all these values. Now, we got the value of V1 here, okay, and V2 here, and V3 here. We will distribute them in this table. We will write V1 here and V2. We will add one more column and we will write V3. So we will make a new column in here and write these values. So this is 0, this is 3 for V2, and this is 1. And we do the same thing for the W's. We will add W1 in here, W2, W3, W4, W5. And we will add a new row with the values of these. So W1 is 4, W2 is 3, W3 is -1, W4 is 1, and W5 is 3. Okay, why do we need these things for? Let us see what we do next. So we made that table. Now let us rewrite it again. Here we go. And now we circled the ones that we highlighted above there to indicate that they are basic variables. Okay. And now we got the values of the V's and the values of the W's. Okay. Now what we do next? Next, we will try to fill the cells that are empty, which means we want to know what is this and that and this and this and that. We want to fill these out. So let me remove these circles so that we don't confuse them with the basic variables. Oops. Okay. Okay. Now, what's happened? Sorry for that. Okay. Okay. So let us fill these empty sets. And here is the way. Now for the values, it's Zij minus Cij. These are the entries of the objective row, if you remember, where Xij is non-basic. Now the basic variables are, are represented by the cells that has circles, that has numbers inside them. The other ones are non-basic variables. And how we do this? We add Vi plus Wj minus Cij, which means to know what I shall write in here, what I do, I add this number Vi, V1, and W1, add them together, and subtract from them the C11, the 9. So we will obtain here -5. Okay? Okay, again. Now to compute the value in here, we use this. So it is V1 plus W1 minus C11. This is C11, which is 9. So it is 0 plus 4 minus 9. So in here we have -5. Okay, so let me clean all that. And now here we have again, we have what? Okay, so sorry, we have -5, so let us write it here. Okay, now to compute this here, we will add 0 plus 3 minus 6. Oops. Sorry. We will say 0 plus minus 1. Okay, minus 6, so we get -7. So let me clean the circles in here. So we get -7. Now to compute this in here, we add 0 plus 7 minus 7. So we get 0. Now to compute this here, we will add 3 plus 3 minus 5. So we get 1. Compute this. We'll add 3 plus 7 minus 10. We get 0. Compute this. We add 1 plus 3 minus 4 is 0. Compute that. 1 plus minus 1, which is 0, minus 9, which is -9. Now to compute this, 1 plus 3, it is 4, minus 10, it is -6. Now we have values in all cells of the table. Okay, now we want to do the next move, which is to find which is the entering variable and which is the departing variable, and according to that we will add and subtract some values, and then we obtain a new solution, and then we repeat the process again and again. Okay. Now, if we look at the values we got, so let me clean them and copy a clean table. Okay. So now we want to choose the entering variable and the departing variable. And how we do that? And let me copy and paste this statement. Now the entering variable is where zij minus cij, the values we have computed. Now the values we have computed -5, -7, and 0. It was zij minus cig, right? Those were the values we have already computed. Now we will look at them, all of them, for the non-basic variables. Okay, so these are the numbers without the circles. We will take the largest positive one, which is now this, and this corresponds to x to 1. It equals 1. So this is the entering variable. Okay, so this is the entering variable. Sorry, this is x22. I'm sorry. x22, this is the entering variable. So we have the entering variable here. Now how we choose the departing variable? Okay, the departing variable is the following. So we start at this point here where the entering variable is, and then we will try to make a loop. We will move horizontally and vertically. So we move horizontally and make a corner moving vertically, but that corner must be at a basic variable. So I want to make a loop, I want to play, I want to move vertically or horizontally, okay, till I find a basic variable, then I make it a corner, move vertically till I find another basic variable, make it a corner, move horizontally till I find a basic variable, and keep this playing till we go back to the place where we started. I mean here, if I want to move this wheel and stop here, and then I want to make this a corner, if I go up, I don't find a basic variable. If I go down, I don't find a basic variable. So this will not help me to be a corner, this spot. So I need to keep moving till I find a basic variable, which is okay here. Can this be a corner? Yes, it can, because I can go there and stop here and find another basic variable. Can I make this a corner? Let us see. If we move here, we find a basic variable. Okay, we can make it a corner. Oh, okay, so we can go back. So we go back to here. So this is a loop. Why do we need this a loop? In this cell, we will add something. In this cell, we will subtract. So it is alternating. Add, subtract in the loop. And here we will add, and here we will subtract. We will add and subtract the same amount to every one of these cells. What that amount is, it is the smallest value I found in my corners in the loop, and the smallest value in the loop of of basic variables. The corners are at basic variables. So if we look at the basic variables, the corners, they are 30, 40, and 60. Okay, so what I will do, we will take this, the smallest one is 30, right? So I will add and subtract 30 according to the signs I made. So we will subtract 30 from here, so this will become 0, and this will be the departing variable. We will add 30 here, and this will become 70. We will subtract 30 here, and this will become 30. We will add 30 here, and this will take a new value, which is 30. Now, this cell is an entering variable. It was non-basic variable. It is a basic variable now. And this cell is a departing variable. It was basic and it is now non-basic. So we need to copy the same table again, but this time with what this thing is. This time is with the new adjustments. After adding and subtracting, now we said we have 0 here. Here it is. Now it is empty. And we have 30 here. Here we go. It is 30. Good. So we got a new table. Good. For this new table, we will have V1, a new V1, a new value for V2, a new value for V3, a new value for W1, and also W2, and W3, and W4, and W5. And how we get these values? We will compute them similarly. We go to the basic variables. This one's in here. These basic variables, they are now new basic variables, right? Because we have added and subtracted. Something. Sorry, what is this? Okay. We have added and we have changed, the basic variables. Okay. Now we will do the same thing. V1 here, we will have V1 plus W1. No, sorry, we will go to this one here, which is 1, 2, which is C1, 2. So we will have the V1 W2 equals C1, 2, which is 3. Now let's go to this one here. This is C1, 5, which is also 3. It is in here, right? 3. So this is V1 plus W5 is 3. Let's go to this one. This is C21. C21. So this is V2 plus W1, and that's equals 7. Okay, let's go to this one. It is C22. So we have V2 plus W2 equals C22, which is 5. And what's about this? This is C23. C23. So it is V2 plus W3, and this equals 2. And this one is C31. C31, right? Yes. And its value is 5. So this is V3 plus W1. And this is C34. And the value is 8. So this is V3W4. Okay. Now we need to find values for these V's and W's. Okay. Because V1 is unrestricted, so we may assume V1 equals 0. This will give us W2 equals 3, right? So we will have 3 in here, and we'll have 0 in here. So again, V1 is 0, so W5 is 3, right? And now we have W2 to be 3, so V2 must be 2. Now V2 is 2, so W3 must be 0. Now we have also W3 is 0, so W1 is, sorry, no, I got V3 now. I got, okay, and I got W3 somewhere. Do I see W3 somewhere else? No. Okay, what else I have? I have V2 equals 0, or, sorry, V2 equals 2, so W1 equals 5. Now, since W1 equals 5, then V3 is 0. Now, since V3 is 0, then W4 is 8. Okay, good. Now I got the values of the V's and W's. Now I will use them to obtain the values. So, okay, let me re-highlight that. To obtain the values of the cells that are not highlighted, which means the variables that are not basic. So we compute V1 plus W1 is 5, minus 9 is minus 4. V1 plus W2, W2 is 3. No, I don't need that one because I will go to a basic variable. V1 plus W3 is 0. Minus 6 is negative 6. Now for this one, V1 plus W4 minus 7, which is 8, which is 1 here. Sorry. Yes, 8 minus 7 is 1. Now I go for this one in here. W2 plus V2 plus W4, which is 10. Minus 10 is 0. I go for this one in here. I get minus 1. This is minus 1. I go for this one in here, which is minus 1 again. And for this one in here, which is minus 9. And for this one in here, which is minus 7. Okay, so we have computed these values. Why we computed them? We will go to the largest positive, and take it as the entering variable, which is this. So this will be our entering variable, largest positive. What if we don't have a positive? Then the algorithm stops, and that means we reached the optimal solution. So now the entering variable is x, 1, 4. Okay, so entering variable is x14. Okay, so we got the entering variable x14. How we get the departing variable? And to do so, let me copy this table again, but a clean one, okay? So that we demonstrate how to get the departing variable. This is the table we have just computed, but cleaner. Now we chose the entering variable. The entering variable is x4, and it is here because this is the positive, x14, sorry, the only positive value. Now we want to make a loop starting from here, which means we want to go either horizontally or vertically, reach a basic variable, and then go horizontally, reach another basic variable, go vertically, reach a basic variable, horizontally, basic variable, and so on until we come back to where we started, but the corners shall be at basic variables. We cannot move that way because if I want to move vertically, I will not find basic variables. So we cannot move that way, but it looks that we can move this way. I cannot stop here because this is not basic variable, so I cannot make it a corner, right? So I have to keep moving till this one. Now move horizontally till we find the basic variable. We are here. Okay, move vertically. We are here. Horizontally, we are here. So the corners must be at basic variables, and we are back. Now what we do, we will add here. This is addition. Now subtraction. So we start addition at where we started the loop, and then subtract, addition, subtraction, addition, subtraction, until we come back. Okay. Now here we will have addition. Here we will have subtraction. Here we will have addition, and here we will have subtraction. Okay. Now what do we add and subtract? The smallest value, the smallest corner. So we will add and subtract the smallest value, which is, which one? Is 30, right? So we will choose Now this one to be the departing variable. This is the smallest one. So departing variable is x12. Okay, now what we do, we subtract 30 from the ones that have minus. So this will become 0. This will become 20. This will become 80. Okay, and we add 30 to the remainings. So this will become a basic variable and we take 30. This will become 60, somewhere 60, and this will become 70. And we get a new table. Okay, and for that new table, if we want, if there is a need to do one more step, then we will compute another V I's and WJ's, right? But let us see, do we need to do one more step or not? Actually, okay, let us see. After we do such changing, we will have to do computations of the Zij minus Cij. But I need to clean this table. So, yes, yes. After doing so, I will get this clean table here. Okay, so we got this clean table. But now notice that we have um, different values for the V's and for the I's. This is the table we shall end up at the end. So I don't have it written as a copy and paste, but let us compute them. Now we got this table, and let us clean things from there. So after computing the entering and departing variables and doing that computations, clean the tables with the new basic variable. So what happened, we chose this to be a basic variable. It is here now, congratulations. And we canceled this, we departed this. This is not a basic variable anymore. So we got a new table. So departing variable, entering variable, a new table. That new table requires the values of V's, another values of V's, and W's, okay? And we will use the values of V's and W's to find the values of the empty cells in there. And we will see which one of these empty cells has the largest positive value, and then we choose as entering variable. And in the same way as we done before with the loops, we can decide which one is the departing variable, and we proceed. Okay, so let us now compute the VI's and the WI's. Okay, now according to this table in here, the very last table, we will go to the basic variable, which is now here. This is C14 and it is 7. And this must be V1 plus W4. It is C14, W1, V1, W4. And also, if we go here, this is C15 and the value is 3. So this shall be V1 plus W5. Again, we go here. This is C1, sorry, 2, 1, which is 7. So we go to V2, W1. Now we go here. This is C22, which is 5. And so this is V2W2. For this one here, it is C23, which is 2. So it is V2 plus W3. Okay, now this one here. It is C31, which is 5. So this is V3 plus W1. Now for the very last one, it is C34, which is 8. V3 plus W4. Okay, good. So make V1 equal 0 again. What we get, W4 must be 7. So this is 0, this is 7. And because W4 is 7, then we get that W3 is 1. Where is W3? And this is 1. Negative 1 or 1? 1, okay. Three and 4. Okay, again, let me see, please. So W4 is 7, and therefore we must have. Okay, no, I made a mistake. W4, I pointed this wrong. Okay, W4 is 7, so V3 is 1, so V3 is here. Okay, V3 is here. Now, what else we have? We can do computations actually. What else we have? Okay, V1 is 0, so W5 is a 3. Now, what else we have? Whereas V3 is 1, so W1 is 4. Now, W1 is 4, so V2 is a 3. V2 is a 3, so W3 is negative 1. Now, V2 is a 3, so W2 is 2. Good. Now, why we need these things for? Because we want to compute the values here. Now, to compute this value here, we add 0 plus 4 minus 9. This is negative 5. In here, 0 plus 2 minus 1 is minus 2 is negative 1. 0 plus minus 1 minus 6, it is minus 7. And now in here, 3 plus 7 minus 10 is 0. 3 plus 3 minus 6 is 0. 1 plus 2 minus 4 is negative 1. 1 plus negative 1, which is 0 minus 9 is negative 9. 1 plus 3 minus 10 is negative 6. Now, if you pay attention to the values in here, so let me highlight them this way. We will be looking for the largest positive number, but we don't find any. So we will write, since there is no non-basic, these are the values of non-basic. So I will highlight this, the non-basic variable with positive value, then we reached the optimal solution. Okay, so what is the optimal solution? It consists of these values. The basic variable here, which is x14 is 30, x15 is 70, x121 is 60. Well, I will write all that. So these are the optimal solution. So I'm saying optimal solution here. What I mean, okay, x14 equals 30. So from plant 1 to warehouse 4, 30 units must be shipped. From plant 1 to warehouse 5, 70 units must be shipped. From plant 2 to warehouse 1, 20 units. and here x22 60 units, x23 80 units, x31 70 units, and x34 80 units, and we will have the remaining to be 0, which means from plant 1 to warehouse 1 we send nothing, we send 0, and from plant 1 to warehouse 2 we send nothing, from plant 1 to warehouse 3 we send nothing, from plant 2 to warehouse 4 we send nothing, from plant 2 to warehouse 5 also we send nothing, and from plant 3 to warehouse 2, from plant 3 to warehouse 3, and from plant 3 to warehouse 5, all of these must be 0. These are the non-basic variables, and they must be 0. And these are the basic variables, and they give me the solution that minimizes the cost. And what is the cost? The total cost, the minimal total cost, how we compute that equals what? Just simply multiply the numbers in green, which means 3 times 30 times 7, 70 times 3, 7 times 20, 5 times 60, 2 times 80, 8 times 70, 5 times 70. Do all this multiplication and add them together, and then we get the optimal solution. And that's all about the transportation problem.